Hello, my name is Steve Yap, and today I'll be presenting my Statistic project, which analyzes financial data from Indonesian pharmaceutical companies. Okay. Let me start by outlining the scope of this research. The industry focused on is pharmaceuticals and consumer health products, and the period covers 2022 to 2025. I selected publicly listed 10 publicly listed Indonesian pharmaceutical companies, which are on the screen right now. With 10 companies over 4 years, this gives me a total of 40 observations, forming a balanced panel data set. Next is how the data was gathered. This project uses secondary data, meaning I didn't collect it myself through surveys, but pulled it from existing public sources, specifically each company's annual report, their audited consolidated financial statements, the financial position statements or balance sheet, and the income statement. From these documents, I extracted 6 key figures for each company, which are net income, total asset, cash and cash equivalent, current liabilities, net sales, revenue, and trade receivables. These 6 numbers are the building blocks for all the ratios I calculate later. The variables are now the 3 variables used in this study are my dependent variable, which is Y, is return on assets or ROA. It measures how efficiently company converts its assets into profit. It's calculated as net income divided by total assets times 100%. My first independent variable, X1, is the cash ratio. It measures company's ability to cover short-term liabilities using cash on hand. It's calculated as cash and cash equivalent divided by current liabilities times 100% again. My second independent variable is X2, is receivable turnover. It measures how efficiently company collects payment from customers. It's calculated as net sales divided by trade receivables. Slide 5, the next one. Because my data set combines both cross-sectional data at 10 different companies and time series data from 4 different years, the appropriate method is panel data regression. This approach lets me capture pattern across companies and across simultaneously, which a simple linear regression couldn't do. Next slide. To reiterate the data sources, everything used in the research is secondary data collected from each company's annual report and audited consolidated financial statement, which are publicly posted online by the companies themselves. Here are a few examples of the actual source documents I pulled from annual and sustainability reports from companies like Soho, Piradim, and Fafros. These reports contain the audited financial statements I used to extract the raw figures. Okay, this slide explains my workflow. First, I organize all the raw financial data into an Excel spreadsheet: company name, year, net income, total assets, cash and equivalent, current liabilities, net sales, and trade receivables. From there, I calculated ROA, cash ratio, receivable turnover for each company year. You can see snapshots of the data set on the right, which are 10 companies each, values for Y, XI, X1, and X2 across 2022 to 2025. And once the dataset was complete, I imported it into a statistical software, in my case eviews, to run panel data regression using ROA as the dependent variable and cash ratio and receivable turnover as the independent variable. Finally, I then interpreted the results by looking at the coefficient and significant levels to see whether these ratios actually affect ROA. And here is, but before running the regression, I looked at the descriptive statistics for the data sets, which are as follows: the mean, median, maximum, minimum, standard deviation, skewness, and kurtosis, or curtices, for each variable across all 40 observations. This gives general sense of the spread and general tendency of the data, and the Jark-Barra test here checks whether the underlying data is normally distributed. This is the or heteroscedasticity test. It's full one. Specifically, the Glacier test to check whether the variance of the residual is constant across observation. If the heteroscedasticity is present, it can affect the reliability and the standard errors in the regression. So this is an important diagnostic step before trusting the results. Now I move into the 3-candidate panel regression model, starting with the common effect model, or CHEM. This is the simplest approach. It pulls all 40 observations together and estimates a single regression line, ignoring the differences between companies or time periods. Differences between companies or time periods. Sorry about that. The second model is the fixed effect model, or FEM, but unlike CHEM, this model allows each company to have its own intercept, capturing company-specific characteristics that don't change over time. Here you can see the model has a very high R-squared, is about 0.99, suggesting it fits the data closely once individual company effects are accounted for. And lastly is the third model is the random effect model, or REM. This treats company-specific differences as random rather than fixed, which is more efficient approach of certain statistical assumptions. Hold the output here uses the Swami and Aurora estimator for the variance components. The model testing of Hausman test, with 3 candidate models I needed to formal test to decide which one is best. The first is the Hausman test, which compares the fixed effect and random models. This slide shows part of supporting output used in that comparison. This continues the Hausman test output, which the results of the test tells me whether the fixed effect model or random effect model is statistically preferred for this dataset. The second model test is the Langridge multiplier, or Bruch-Pagan test, which compares the common effect model against the random effect model, helping determine whether the random effects are even necessary or whether the simpler pool method would suffice. Having selected my final model, I ran further diagnostic checks. First, the Jogbarat test on standardized residuals, which tests for normality. The probability value here indicates whether the residuals are reasonably close to normal distribution, an assumption underlying valid regression inference. Second, I checked for multicollinearity using the variance inflection factor, or VIF. The centered VIF values for the independent variables are both under 2, which is well below the common threshold of concern, meaning the independent variables aren't overly correlated with each other, so multicollinearity isn't a problem here. So this slide shows, slide 19 shows the supporting test for confirming whether fixed effects are actually needed. The redundant fixed effect test, both the cross-section F and chi-squared statistics are highly significant, which supports retaining the fixed effect structure over a simple pool model. And this slide presents the full Langridge multiplier test for random effect, including the Bruch-Pagan, Honda, King Wu, and other variants. The cross-section test statistics are highly significant, confirming that individual companies' effects are statistically meaningful and shouldn't be ignored. To wrap up the analysis, visually I plotted a standardized bell curve converting cash ratio, receivable turnover, and ROA into z-scores. They are comparable on the same scale. The chart shows how each identified company year observation is distributed relative to the mean, and highlights the company years are notable outliers, sitting several standard deviations away from the center. That concludes my presentation. Thank you for your attention. That's all. Thank you for watching.